So since we are talking mostly about AI today, right, I wanted to start this presentation with something a bit easier. What I'm going to try to do is actually demystify a few parts of it, how the LLMs that we actually use work. And Lucy probably gave me some AI written name of the presentation, so I just decided to shorten it to LLM refresher, right? That's all you guys need to know. All right. So why do we want to continue talking about AI and why it's important for us, right? It's obviously going to be transforming all of the knowledge-based work that we're all involved in, right? Whatever we do is going to radically change over the years to new things that we can probably not foresee, right? But what I want you to get from today is a very simple explanation that is probably too simplified, right? Of how do these things work, what you can use them for, and how to not be afraid of them, right? And to not get into that fear of the unknown, right? Of what that actually happens behind the process that I'm using right now. And obviously then we'll be able to leverage it better for more important things. So I wanted to start with something that is core of this, which is LLM training. And I have a few riddles that I hopefully people can be able to answer. So if we go further and say, have you ever thought of using words in a mathematical equation, how that would look like?
No.
Oh, you tried already. I know you did, right? But let's think about these two simplified examples. So what would you get if you subtract man out of king and add a woman? Anyone else besides Elisa? Any guesses?
Queen.
Congratulations, Stephen. Yes, that's exactly right. So this is kind of how you can think about it, right? Okay, so the words have meanings, right? And we can add things and subtract from them. How about king minus man plus young? Exactly, Anais. But if you think about it, right, we have subtracted man, so it's not a gendered name anymore. So it could be a princess or it could be a prince. It's ambiguous at that point. So if we try to map it on a 2D graph, it would look something like this, right? We have an axis of gender and we have an axis of age, and with all of these four words placed on it. Now, let's try to complicate it a tiny bit more. What if we added another axis, right? For specifically power of a person, right? We would get something like this at that point, right? So, for example, we could place the word peasant somewhere over there that is not gendered, but has no power whatsoever in that age, right? And is also not related to the age of a specific person. What about adding a fourth axis around time period? So if we would look at king in a modern age that has the same criteria we defined before, that would potentially be something like president. What if we add a fifth, or a sixth, or a 12,288th axis for this? And that number is kind of important because that's actually the number of parameters that ChatGPT version 1 was actually referencing words to. Is anyone with me so far?
Yes.
Right. So what we've described before on here is actually the process of training the LLM. We just dump the words into it, we form these relationships between them, right? And then we proceed to kind of build further on top of it. And this kind of gets to how LLMs actually understand our natural speech when we type words into them. So the problem here for computers is context in our language is key, right? A word can have several meanings, right? It can mean one thing in one context, a different thing in another one. Punctuation, intonation, and everything else is very important, right? And even sometimes capitalization. So the joke that I was preparing for today, if Lucy asked me to make a quick presentation and I answer, yes, queen, how would LLM think, is Lucy a queen? Does she have power over us here? Yeah, right. So the phrase I wanted to use for this example specifically is one ring to rule them something. What does the word ring mean in this sentence? Why is it capitalized, right? Is it a piece of jewelry? Is it just a geometrical shape, right? How can a computer determine what it actually means? And that's how we kind of transition to the power of vectors. Quick refresher, a vector is a mathematical concept that implies something in the 3D space that has both amplitude and magnitude, right? That's over your head, you can Wikipedia it later, or ask the LLM to explain it to you easier. But the point is that what we form is a massive cloud of words, and they are all positioned in a specific way that helps them relate to one another based on how close they are to another, right? All of those massive words and all of those many parameters. So for example, in this massive word cloud, in this context, we would probably have the words Tolkien, book, one, or Ian McKellen close together because they're all related to the same concept, right? So what we do next is actually go through the 3 stages that an LLM goes through to understand us and to give us back the answer. So what the LLM does, it embeds what we typed into it, first into tokens and then into vectors. A token is just a representation of the word, don't worry too much. Then it goes through layers of transformation, and this is specifically why these LLMs are called transformer models, right? It first does an attention phase where it tries to guess based on all of the words you used in a sentence and their context of what do you actually mean when you ask one ring to rule them, right? It tries several different ways to rejig it to see, okay, if I change this word for that, would that mean have more probability or less, right? It arrives kind of at a conclusion and then starts transforming it with a forward lookup of going, well, if this means that, what would probably be the next word based on the other words that are close together to it? And after it gets a consensus and thinks about, well, probably they meant this, right? It unembeds that result back into our natural language. And that's pretty much it that I wanted to cover.